So I got up this morning realizing it's garbage day, and I got real busy collecting all the garbage in our house and our recycling and all that kind of stuff, and getting it all piled up into the containers and ready to take out to the end of my driveway. I opened my garage door, and none of my neighbors have put anything out yet, because garbage day is Friday and today is Thursday, February 8th. Yeah. So that's how I started my day today. So here's something interesting too. I came in to turn on the computer here and get ready to start work on this. And lo and behold, what did I notice? This interesting observation here. See this capacitor? And one of the wires is broken off of it. So this capacitor is not connected right now. Now I was operating this radio without this capacitor connected. Let's try that again. Is this thing even necessary? What is it? You know, no. First thing, we'll figure out what this is. What is this anyway? It's connected to. This is the rectifier tube here. It's connected to the to a terminal on the rectifier tube socket. Now, what's the story with that? And the other wire comes to this terminal, and then it loops around and gets very hard to follow after that. I have the feeling, I don't think it is, I was going to say I have a feeling, let's see, ties to this terminal, and then we've got all kinds of stuff coming off this terminal, all kinds of stuff. So this is just one component of, there's a what looks like a gigantic, something odd there, a gigantic resistor here. Okay, one lead goes to a terminal with a gigantic resistor on it, big high wattage resistor. A small resistor here. Another resistor. Let's do it now. So this probably is on the schematic is distributed, you know, across a line. So these components will all be shown, you know, connected to one star point, so to speak. They'll be spread out, so it'll be a little tricky to find this necessarily. The other way is to come from the tube socket, which is probably a much better way to track it on the schematic. So where are we on this now? This is the this is the replaced tube. So the schematic talks about a different tube here. So well, what we need to do then is see the terminal that's connected here and to the capacitor. It appears to be connected to nothing else. What would that be? What would that be? Nothing else tied to it? Hey, this is just getting weirder and weirder. Get a big capacitor tied to a terminal in a tube. Why would that be? So let's take a look at this, and while you're looking at that picture, I'm going to freeze the focus, the automatic focus here. Which is holding very steady right now anyway. Oh, okay, what a schmozzle in there. So the wire we're trying to trace or look at is this one here. This is still connected to the capacitor, connected to the, okay, I got the answer already. I didn't even ask the question, I've got the answer. This is a grounding terminal, and I'll bet you this is, I'm pretty sure what we're seeing, what are we seeing down there? It's a hole through which a wire is coming up to this terminal. Is this really grounded? The reason I think it is because it's broken off the ground terminal of this capacitor. So I'm thinking this is probably just connected to the chassis with all this other stuff hooked up to it. we'll have to test this with a ohm meter to get more information about what's going on here. The other wire, oh, look at this capacitor here, cracking. The wax is cracking open right at the end here. So here we are now. Let's see the key. There's the key. So pin number 1 is the empty pin there. This is pin number 1, and this is going to be pin number 8 here. So pin number 1 is usually, I'll take it back, I was going to say a metal tube. This isn't a metal tube, but pin 8. There is another wire attached to it. Is there? Yeah, there is. Okay, that makes a little more sense. Okay, a little more sense. Let's find out what pin 8 is on the rectifier tube. And what was the tube again? What tube was in there? 6x5. So 6x5, that's right. Okay. Let us study the book. 6x5. I wonder why the fellow picked 6x5 to put in this radio. If it is some suitable. Well, here it is. Not much to it. Pin 8 is the cathode. So a big capacitor on the cathode of a rectifier tube. That might make sense. It might be just a handy place to connect it. Connect it in another place, it may look more sensible. We got to look at the schematic now. What's going on the cathode of the rectifier tube, even though the schematic is around a different kind of tube here? Okay, here we go. So cathode, straight to ground. If that's the case, then the capacitor is connected one lead to ground and the other lead to ground. That doesn't make any sense at all. Pin, wait a minute now. Oh, that's right. Different tube. Don't study this too closely, Joe. Don't study this too closely. We just know pin. We know the cathode in this arrangement is solidly grounded. Now with the other tube in there, would somebody? It's the wrong tube, Jim. You're totally out of whack here. Were you yelling at your screen there? Yeah, I better stop and drink some more coffee here. Here we are. Okay, this makes okay. Here we are. What is going on here? So we have the positive coming out here. This should be grounded. Here we are up here. So there's a ground here. That's the heater, which is what here? Well, what have they done here? Who's who? The heater's got to be going here to this X. That's the heater and the light bulbs and all that. The cathode must be turning the corner and going up this way. Then you get your 250 volts. And right away you encounter a capacitor. So is that what that capacitor is? And the other end of it hooks up to a point where there was a bunch of resistors, which there were. Let's see, one of them is 820 and the other one is 2200. So I'm just going to look and see what I can see here. Other lead. I can't really see them there. Oh, wait a minute. Yes, I can. Just bear with me here. 222, 2200. So one of them is 2200 ohms, and that matches right here. So that's got to be the guy. There's also a gigantic high wattage resistor in here. That could be that one, 820 ohms. Yeah, this is that weird parallel thing I talked about earlier. Why would they do that? And I still don't have a really good answer, other than it's just possible that the biggest wattage resistor they can get a handle on was the one they put here, and there's still more watts to dissipate, so they stuck another and arranged these values. So together this is something like, I'm going to guess, 600 ohms through here as a guess. So I think this is what it is. Could it be this? It could be this one. That's just grounded. So if it's this one, the broken wire would be leading to a ground. If it's this one, the broken wire leads to these resistors. Isn't that thoroughly confusing here? I mean, it's very common to put a high wattage resistor and turn this into a pi filter and not have any inductors involved. That's what this is basically. And we can't, that looks, I'm going to have to say that's 40. 40 and a 20. And a 10 way over here. 40 and a 20. Now, what's the metal one? Now, the metal one, this is a little bit disturbing, because there is a metal one in there with 3 sections. Are these parallel in some way? The capacitor that's laying free was paralleled in support of the originals. So we have 1, 2, oh, look at this. Look at this, C101. So right here they're telling you this is 2 of them, and this is a separate one. 40. Okay, let's poke around the radio a bit here. Poke around the radio. First of all, is that terminal a ground terminal or not? Which terminal? This is the terminal from the wire that's broken off the capacitor. $800 ohms. What's that sound like? Doesn't that sound like those 2 resistors in parallel? Almost 900. Okay, and here's the 2 resistors. A little hard to see. One's there, that's the 2200, and then there's this big one, which I can't see the size of. It's probably the 600, and right there in parallel. Literally in parallel. So that means this is coming in on the non-grounded side. That means this should be the 40. This should be the 40. And it doesn't say. I'm on my way to replacing it anyway, but let's give it a go. Let's give it a go. Big C. It's slow. It takes slow on a big capacitor. So 36 microfarads. That's right close to 40. It's actually testing pretty good, isn't it? 40 microfarads. Well, as you know, this radio is not showing any sign of humming or anything like that. I'm going to get rid of this though, because look at it. And I'm going to stick a new one in there. We'll go up in size just a wee bit too. Okay, I'll get that done. I think it might be a good idea to operate this radio again. Just see how it does. So, broadcast band, volume down, tone wherever the switch is on. Okay, just a quick safety check. I had to whip this chassis out of my shop yesterday, and so I disconnected everything and reconnected everything, I hope. Here we go. Okay, tube is warming up. I have acquired some LED miniature lights to replace the bulbs in here. I should do that maybe, because it's good to have these lights come on and remind you that the radio's operating, that the power's on. Pretty silent. No hum. No nothing. There we are. Okay, got some volume. Tone thing appears to be happening. What did we tune this guy? So I want to close the capacitor. That's where the stations are. Last time, nothing. Wouldn't expect any difference this time. And there's also a short that shows up. Maybe not. It's a little odd. There was a... Oh. What happened? Oh. So what can happen in a radio like this, and I don't think this is what's happening right now, but you replace a part of this sort, and the voltage inside the radio can go up. Then other parts start feeling it, and maybe they give up the ghost. I don't think that's what just happened. What did, is it the volume? Tone? It's making the level go up and down like that. Band switch. Oh, you know what? This is where we're going next. Band switch. It's possible the band switch is so bad, and this is why the radio's not receiving. Let's take a close look at it before spraying it with stuff. Okay, so here's the band switch here. Well, you know, just think about how much dirt there is on all the parts in this radio, and then you know, how could the switch not be covered? How could that ever happen? This part looks fairly dry and clean. You know, I don't know what I'm expecting to see, but back here it looks fairly clean. Clean of oil, anyway. Oil and the dirt that oil collects. But it could have corrosion products on it. They're non-conductive, and they'll interfere with the switch. Let's give it the expensive stuff here. Switches. The radio's off right now. I find with this stuff that I'm using, a lot of gas comes out before you get any fluid. Fluid dripping everywhere but in the switch. Switch has become hard to turn now. I think the metal is chafing much harder. Sounds pretty good. Okay, let's give it a try. yeah, I sprayed. I don't think it's this kind of cleaner at all. I didn't have any of this at the time. I sprayed some other kind of volatile cleaner on a band switch. Oh, smoke coming out. Smoke coming out. Smoke is coming out. Smoke came out. Turn it back up. More smoke coming out of the back. What's smoking here? What is smoking? Set a fire any moment. Well, I'm going to switch this. She's burned clear. That's a power company term. When you have a short circuit and a big power system, it's... What happened? Where'd it go? Something more burning now? Oh, it is burning. She's burning up in there. We're talking a big problem here. In the back there. Watch it now. I'm telling myself, be careful. I'm going to electrocute myself holding this camera up here. A full flame came up in the back there. And I just put the camera away. That's phono. There's smoke there, isn't there? Way in the back. More light, more light. Oh, I can smell the ozone in here. Some people say ozone's good for you. I think I just saw another puff of smoke come out. Or did I? It just be dust on my glasses. I think it needs more cleaning. We need more fuel on the fire here. It was kind of in the back, eh? Okay, well that's pretty exciting stuff. Hey, that's what makes it fun. Yeah, let's spray a little more in there, towards the back of this switch here. I'll just air gas out of this. Let's go again. Quickly, get the other camera. Or just get this one up close. Why don't we just try and get this one up closer? Come this way. Oh, there's the smoke again. She's really smoking and popping flames. She's smoking and popping flames there. My tripod decides to collapse right now. Get your eyes on it, Jim. Get your eyes on it. What is it? That's burning in there. Whew. Somehow the radio continues to operate through this, too. Well, we kind of missed the flame action there. Let's just see if we can reinitiate. Gentlemen, start your engines. Oh, there's smoke coming up again. Surely to goodness, it can't be good for the thing to continue to produce smoke. Oh, what was that? I heard a snap that time. Pretty quiet on the other band. Let me turn it up. Oh, still there. Still there. So other than catching fire, this radio is working fairly well. aggressive hose down. So for aggressive jobs, what have I got here? I have got a can of, whoa, throttle body. Oops, wrong camera. I'm showing it to the other camera here. Throttle body cleaner. Whoo, this stuff is incredibly volatile. And it's powerful. Gonna eat anything. But the thing is, it puts a lot of fluid out. Now I got this off. I'm not going to turn it on. I'm going to do this and go for a coffee because this stuff will definitely flame up in there. I'm just going to hose her down. I'm not recommending people use brake cleaner on their radios. I've got like 4 cans of this stuff. Got to use it up. Okay, we're gonna let that sit and vaporize. I'm gonna go drink some coffee and then we'll see if we can start another fire here. This is exciting. So there's really a couple things that can be happening with this switch. One is the contacts, which are sliding over each other, are not making good contact. And because of that, there's a heating effect. And the heating effect is so strong, the contact and the amount of current available, all is just right to heat it up to the point where smoke is produced. So that's one possibility. Contact not quite being made properly. Another one is 2 terminals that have a significant voltage between them, a couple hundred volts, and a pile of dirt down where the terminals poke out. And the dirt is shorting them. So the problem here is current flowing through dirt. Which one it is? Gee, I don't know. How can you possibly tell? I can get in there with some kind of cleaning brush. I don't think that's possible. There's no way to get in there. So it's a question of just flooding it and working it. Okay, talk about working it. Let's work this switch now. Everybody's eyes on the smoky spot. I really don't like that. I don't see any component back there, which is what I'm kind of freaking out about. That there's some kind of component that's doing this. But it doesn't look like it. It's not the right kind of smoke. It keeps reoccurring. Okay, right. There we go. Power on. Power's on. Watching now. We are watching. If it starts to burn, I'll put it out with this. I'd have a bonfire in my shop if I did. Hey, we're talking about fires. Where's my fire extinguisher, which I have always not quite at the handy? I don't know, but I don't want to take off right now and try to find it. So no smoke at this point. Stick your nose in there too far, Jim. Yeah. Get a free nose job. Okay, here we go. Watch for smoke now. Looks like the throttle body cleaner did the trick. Okay, I think that fun's over. Don't think any damage was done to the radio. At least I hope not. So to try to keep a mental eye on this anytime I turn on this radio for the next while. We were trying to tune in something and I was expecting the capacitor to short, and it didn't. The capacitor's almost closed right now. Just a sec here, I've got my... Not exactly the nicest thing to listen to coming out of a radio, is it? Now I moved this over here for some reason. Why did I do that? Oh, because I'm going to try tuning the capacitor and give you a chance to watch the capacitor here. It's a little hard to see. See, it's almost closed. There we are. Oh my gosh, it's still going. What happened here? I do have some kind of problem in here. It's just huge amounts of dirt. Okay, huge amounts of dirt. Let's try this. Trying to show you there's a lot of air coming out of this thing. Here, I can show you this one. Really blowing hard. Wouldn't normally do this live, but it doesn't matter. Something I don't use very often. Now, do you think that did anything? I don't think it did anything. Okay, volume is normal. That really sounds like plate contact. Power off. Let's just examine these plates a little bit here. See what's up. I have to do this very carefully. So, starting on this side, these ones appear pinched. A little bit pinched. It's not uncommon for these outside plates, this one or this one, to get driven inwards by accident by people doing stuff. Maybe even me. Even pulling in and out the radio out of a cabinet. Sometimes this stuff can get bunged up. So what I'm going to do, I'm going to guess that this is the problem. I'm going to bend these outward. They're not. Second one a little bit too. Can we hear or feel the rubbing? Now that maybe I've eliminated rubbing. I don't know. I'm hearing my finger touch stuff. Yeah, I don't think you can hear these things. You'd have to do a little bit better job to try to hear it. This is very hard to turn. Why don't we loosen that up too? Get this guy a little looser. Okay, so lubricate right in here. Where'd it come out? That made all the difference in the world. That right there. I would have thought there was a lot more to it. So we do have this special anti-backlash or special sliding plate arrangement here. We also have some ground. Let me put this back down. Oh, that's nice to turn now. That's easy. So we want to put a little bit of, let's use it. Let's first of all, brush this off. We have to leave the shop after this because of the dust in the air. Yeah, I think I'm gonna have to. Don't really want to be breathing this stuff in. Yeah, I should have had the vacuum going because it's gone everywhere. Okay, I'm standing back from the radio now. Okay, I'm going to give that a few minutes to kind of, for the dust to settle onto all my stuff, and then I'll come back in. Just in case you think I'm a little crazy about the dust here. Yesterday I was watching a video of a guy looking for uranium. Kind of a semi-amateur guy. I think he was a geologist, I'm not sure. And just at a road cut where some rocks had been cut through and rock was exposed. And over he goes with his rock hammer and a couple Geiger counters or a couple of radiation sensitive devices. And he's already knows of a spot, and he goes, shows his radiation sensor ticking away like crazy, and then he's digging, he's hammering, he's digging, he's banging, he's pulling out pieces, he's holding them up to this sensor. You can hear 50,000 per second, and doing it again and again. And suddenly I realize the guy has no mask on, he has no protection whatsoever, no breathing protection. Yeah, he's outside, but he's only a couple feet from where he's smashing radioactive material with a hammer and a chisel. There has to be some amount of dust in the air. He has to be inhaling some amount of radioactive dust. I don't think that's a good thing. I almost wanted to phone the guy up and say, what are you doing? But of course the video's from a long time ago or some time ago, and I wouldn't know how to get a hold of the guy. But I just thought to myself, oh my gosh, what are you doing? What are you doing? So I don't want to be that. I don't want to be that guy. There's nothing radioactive about this, not that I know of. Anyway, I have had radioactive radios in here. There are some radios with radioactive paint on the dial. Not many, but they are around. Yeah. So let's try this again and see. A, does it smoke? B, does it tune really nicely now? And did we clear the short circuit? That's the idea. Just making sure of a few things here. We're all good to go. Let's go. We're going. Let's step in front of the camera here while Hey, what about the smoke? What about the smoke? Smoke and flames. She's at working. Okay, we're on the broadcast band. There is an antenna connected. Just go way up in the sky here. Ooh, what's that? What's that noise? Anybody home? Don't know what that sound is. This? Okay, tune around. Oh, we did not clear it. We did not succeed. Okay, let's see if we can spot it here. Is this strange ticking interference? The speed of the ticking changes. Sometimes it'll slow right down to. Sometimes it'll speed up. Okay, looking very closely now. Anybody touching? See that last one is bent out there. So those look great. Okay, other end. Let me close it right up. Somebody's rubbing. Seem a little off center. Well, the whole thing can be adjusted sometimes by turning this screw on the back, the screw here. It tends to push the rotor a little bit left or right. Now another good possibility is the problem is right in here. Maybe a stick. This is a sliding ground here, this part. Here, these metal springs here, this is steel spring material attached to the capacitor body. See the rivet? And they even have some terminals out here in case the designer needed those. And then they're probably spot welded here. Little things happening, but you know, when just because I'm pushing here doesn't mean I'm not affecting it somewhere else. They didn't seem to be bad. They seem to be okay. There's obviously a ground contact rate in here, but not one that's relied on. These are the ones that are relied on. Likewise, all kinds of stuff up in here that's going to be, you know, grounding as you turn the dial. Okay, next thing we'll do, we'll try sensitivity here. I have to switch cameras here. I can't, I'm looking at two things at once. I can't be doing that. Come down off the tower. Sharpening this. This is the area. Shut right down. They don't look too close, but maybe they are. That's it. That was it. Seem okay now? Looks good to me. Okay, another problem solved. Now we got a capacitor that works all the way. I didn't hear any stations. Let's try again. Antenna's still connected. Close the capacitor here. It doesn't sound right. Like it's those sounds, they aren't right. You see the ball bearings in there? Just in here. The thing about WD-40 is I don't think it lasts very long. I think it tends to dry right out. Like a good portion of this is volatile gas. Liquid's going to come off and it'll evaporate away. That's why when you spray this stuff you see a lot, and then a little while later you don't see any anymore. Just a very thin film of oil remains. Secret formula. It's tuning very nice now. Nice and smooth. Goody. But we're not picking up anything. Okay, that's enough of that. What's next on the hit parade here? Maybe we should get back to looking at some capacitors back here. So, generally speaking, down here is the audio area, and up here is the RF area. And we should probably, what's my tripod keeps quitting on me there. We should probably just stay in the audio area right now. Clean it up. That's quite a few capacitors right there. 1, 2, this is probably the tone. Reminds me of my electric train set when I was a kid, which produced a fair bit of ozone when you were playing with it. Or is it my dad's razor? What am I smelling here? Just looking for heat. Surprising heat. I don't feel any surprising heat. Okay. So there's a great big honker right here. Look at this guy. Generally speaking, big part, big job. Who to do next? You know what we'll do? We'll do the two that are right across the power line. That's this one and this one. We'll get rid of those. Yeah, that sounds like a good idea. Good idea to me. Let's look on the schematic and just see what size they have in there. My stock's a little limited on these special capacitors. So I have capacitors that are built to go right across the power line, like the ones I'm about to replace. Power line. Here they are right here. So it's just a 0.01. Nothing special. So I'm going to replace those two. Okay, got the new safety capacitors in here, 2 of them. While I was doing that, I had a chance to kind of look up in here, and this big resistor has something weird on it. Let's take a look at that and see what we can see. It's this capacitor with my finger, or resistor with my finger on it. What's that white stuff? Is that coming out of the resistor? I really don't know what it is. Huh. Okay, not much holding it there. So the end of the resistor looks weird to me. This end looks normal, and the other end looks weird. Now, is this some of the debris I just... Yeah, that's what that is. What's in a resistor that could come out like that? It almost looked like something had like a crystal formation. I can't think of what to compare it to, like a snowflake. That's a bad comparison. Is that a bad resistor? So this is the 860 or whatever it was that's in combination with the 2200 right here. Why don't we measure the combination of these two resistors? Or did I already do that? I already did that, and it was 800 or something. I can't remember now, but I thought at the time, well, that's fine. Okay, we won't worry anymore about this. I'm going to be taking this capacitor out soon anyway, and we'll get a better look at the resistor at that point. Who's next on the hit parade here? Well, it could be this guy. I'm going to leave him for now, though. I think what I'll go out, just stick with the idea that we're doing the wax capacitors. That would be maybe this guy and maybe this guy. One of these is going to be the tone capacitor. Oh no, not this guy. The one way in the back here. Hidden down in behind here. Okay. Sit and look at it all day. It's not going to change. Oh, I know what we got to do. We got to look at these two capacitors I took out, which I'm not sure I can test these because where's the lead? I had to cut it right off, flush. So I can't really test these. Not so bad. I mean, it looks like it's had a rough life. It's been in a rough neighborhood. That's what it looks like. This one, the end is popping a little bit right in here. And likewise up in here. You know, it's just a tube with a wax seal at the end. Well, this one's got wires on both sides. And, you know, whatever's happened to this one will have happened to the other one too, I think. You know, these are really important because these two capacitors and these yellow ones I've put in now, as soon as you plug this thing in the wall, these capacitors are feeling 120 volts or so. One of them anyway is going to get 120 volts on it. And it's just as long as it's plugged in. Doesn't matter if it's turned on or not. So these capacitors, if you plug this radio in and walk away for 8 months, these capacitors are humming away for 8 months, quietly, approaching their demise. Okay. Yeah, let's go and have a look at, so what's with my mouse here? I have a cantankerous mouse. My clip lead down here is ready to break at any moment. This clip lead right here. So this could be the moment. No, I made it. Another test. So what we're going to do is we're going to put 50 volts onto this capacitor. And we're going to watch the eye here. The magic eye. And what will happen, this eye, current flow through the capacitor makes the eye close. So a good capacitor will have no current flow and the eye will be open just like you see it now. You see this pi down here? When I hit the switch, 50 volts goes on it. For a brief period, there's a charge that goes into the capacitor. During that time, the eye will close. And then it will open again. A small capacitor, that happens in a fraction of a second. It goes boom, boom, back open. And it should open just like you see it now. Anything less than that, she's bad. She's bad at 50 volts. So here we go. Watching the eye. See it pop right open? 150 volts. Now it's only opening a little wee bit. So this is typical of these capacitors. Now how significant is this in the position it was in? That's hard to say. First of all, you're not going to drain Niagara Falls through a capacitor like this. So a little bit of current flow in here isn't going to be significant, I don't think. A little bit, a tiny bit. If in fact the current flow increases enough, it's going to start producing heat in here. And then you're going to get into a situation eventually where you reach a thermal runaway, where the heat itself is reducing the resistance, and the more current and more heat, and away she goes. Now, in all the years I've been doing this, I've only experienced 2 capacitors heating up, and it's been very recent. One of them was actually sizzling. Actually, both of them sizzled. That's how I knew they were heating up. Perhaps this is happening more and I've never realized it because I don't really temperature check these things. This particular one, the amount of leak in it, this could have probably stayed in the radio for a long time, but who's to say for sure? We don't know. So eventually this overheats. It could produce a short circuit. Now it's a short circuit right on the power line, and the radio can be off and you can be in bed sleeping and this thing starts burning. And then, depending upon what's in the radio, it could communicate the fire to other components. Wax burns. Holy smokes! It's like a candle. Could you burn your house down? I don't know if it would. I don't know if it would get all the way to there. I mean, it's inside of a metal can, right? The chassis. But you just don't want those things happening, which is why I'm changing this out. It won't have any effect on the operation of the radio. Yes, it will. There's a funny hum that can come on a radio that doesn't have proper filtering on the power line. And it's a hum that shows up only when you tune in the station. It's a little odd. Called intermodulation hum. I believe that's what they call it. Okay. Might have to pick another capacitor to do now. Who should I do? I do this big beauty right away? I don't think so. I think I'd rather go after these ugly, dirty ones here. And look at this guy. You can hardly even tell there's a capacitor there. Wow. So on the cabinet, if you remember, I'm just going to tip my camera right over here. All the wear on here. It tells you this radio was not only somebody twiddled those dials a lot, it means it was on a lot. That's how it got all that finger wear. This thing was played a lot. They got their money's worth out of it. And that's probably why it's so dark in here. Just so much time being on. Okay. What a beast. Did I pick a capacitor? I didn't. Yeah, I said I'm going to do these. Okay, we'll do those. The capacitors I'm looking at are around the tone control and volume control, so I thought I'll just take a moment. I haven't really studied the schematic for either of those, so here's the volume control right here, and you can see the sliding part, or the varying part, is hooked up to the grid of the triode on the detector tube, and its signal is sent over to the output tube and out the speaker. So now you can see on the volume control there is a tap here, and look what happens. Oh my gosh, capacitor network going, and there's the tone control buried in there. So my experience with these radios is that this is an area where the engineers kind of go a little crazy, and they come up with their own scheme and scam for controlling tone, and in particular in enabling a loudness type function, which means when the volume is low, the low and high tone is peaked up because of the way our ears operate. We don't hear low and high well at low volume, and that's so that we can focus in on the human voice at low volume. And people whispering to us, we can hear it very clearly because our ears are designed that way. So analyzing this, kind of not worth doing. It's just good to say, look at what this engineer came up with. This weird combination of stuff hooked up to a tap on the back of the volume control. So the capacitors that are on here that would be wax would be this one 006 and this one 002. This is probably a mica capacitor, 68 picofarads. And here's another one down here actually. So looking at the heavy lines on the schematic, how they've been shown, these heavy lines are intended to show the signal path. signal. Interesting, they didn't heavy up this little piece here, but they heavied up this piece. Down she comes. See, inconsistent. They didn't heavy this piece. Down, down, down. Oh, sharp corner. Oh, another sharp corner. Then what is this? Is this the band switch? Yeah, this is the band switch. So as you switch through the different radio bands, this is basically doing nothing, 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 nothing until you get to here. And then it has separated away from the radio output and is now picking up this line. Hey, there's another one of these over here. This line, where's that line going? Hey, where are you going? I thought you were going down to the cartridge. Here's the cartridge. Oh, another network. And you can even see there's a note here. Phonotone compensation circuit for the model 481827. Oh, I've got the 1826 here, isn't it? I got a different one. So this would be the tone control or the tone adjustment or compensation. They like to use the word compensation for toning control in when it comes to a cartridge. And you know, a 0.2. Ooh, that's a big one. So the engineer who designed this probably spent a lot of time on this and on this. There could be standard designs or earlier designs he just built on, because they usually don't dream these things up right out of the blue. They're, last time we did it this way, let's do it this way this time. It's slightly different. And they evolved their radio circuit forward. He says, why is he saying He's saying because he's not sure what to do next. I don't think I'm going to be able to directly identify, like, study the circuit and then look in the radio and figure out what capacitor is what. What I'll do is I'll go at the capacitors I'm interested in, I cut them out, I'll check the size, and then we can peek at this again if we care to, and sort out what it is. But generally speaking, it's not very interesting. You might as well just change these. That's what I think I should do. Okay, we're going to do this one, and I better get a clip lead here because as much as I don't want to forget where they come from, I'm sure if you do this kind of work or something similar, you know the experience of looking away, and when you look back, oh my gosh, nothing looks the same. And I'm going to look away because I want to test this. This is a 006. That was one of the capacitors we saw on the schematic in the area in question. Okay, back on again. Now, what's the guess here? So this capacitor probably didn't sustain any high voltages of any sort, AC or DC or anything. Probably coasting along there, having a good time. Happy that he's in the tone department and not in the B+ department. Things are rough in the B+ department. Okay, so 50 volts, watching the eye. What do? Opens up. But I bet you it won't open up 150. Not at all. So, yeah. Even though he had an easy time of it, you know, that's just like us. If we spent our entire lives on vacation, we'd still end up getting old. That's what happened to him. And I'd like to spend my entire life on vacation, but it's a little late for that now. Yeah, quite late. Okay, I think I'm going to put in the replacement and then we'll go after the next capacitor and check it out too. Okay, next capacitor's out. Let's take a closer look at this one. This one was kind of buried out of sight, so a little hard to observe, and it's part of the tone control, volume control situation. 0.002, I remember that number. Here's the thing, look at the end of it. Now, why would this come out like this? Why, like, what is pushing that out? Okay, could it just be it's angled like this and got very hot, and this is literally dripping out the bottom, this part? Internal pressure pushing it out? I don't know. I don't know the answer to those questions, but it's curious about what is happening there. And surely this is a bad thing. I mean, it's breaking the wax seal, so it's exposing the inside to the atmosphere. It's going to pick up moisture, and yeah, that's not. You don't want your capacitors to look like this. If you buy them and they look like this, don't pay for them. So we are now going to test this guy. Also, we can guess what kind of result we're going to get here. And whoops, wrong camera. And I think I forgot what I was just going to say. I think this capacitor and the other one, if leaky, probably not a big deal. Like, it's not going to hurt the radio. Okay, 50 volts. What do? Pop right open on 50. How come they all pop open on 50? But on 150, hey, it popped open. Let's give it 250. See, it's still opening a little bit at 250, so this guy is a little better than some. And now, while we're looking at this, just to prove this is a brand new modern capacitor, and we're going to test it, doing the same test. And this is to more or less testing the test at this point, because this capacitor has no leak, should have no leak. So starting at 50, watching the eye, she so fast popped right open. Right open 150, 250, 350, 450, right open. Don't touch that capacitor. Well, actually, when I let go of this control, a short is put on the capacitor, so it's drained out. It's probably safe already. But you wouldn't want to charge it up to 450 and then leave it on your bench, especially one that has no leak. It's going to hold the charge. This guy couldn't hold a charge. Couldn't hold a charge. Can't hold his charges. Okay, time for the new one. And what did I say this was? A 0.002? What was it? 0.002. New guy going in. See, and that's why I have the clip leads there, because God help me, I would never remember at this point where it came from. God, I shouldn't call for God to help me with this, should I? Okay, let's give this guy a test now. Capacitors are in. I checked the soldering with my magnifier. Good. Antenna's connected. Everything's good. Volume down. Switch is on. Bench is clear. Here we go. I shouldn't snap that switch so loudly, should I? I almost scared myself with it. Oh, you know what? You have to plug these radios in to make them work. There, let's try it again. Quietly. Okay, we're hitting it 100 volts or so. Once it settles down. So we might get more volume out of it. I might get less. I don't know. Seems about the same. Tone. Still working. And any chance of picking up a station. We haven't done anything here to improve the radio's reception, but it's doing something. Something weird is going on with that tuning. But it seems very, very broad. And it's picking up nonsense. Okay, that's a broadcast band. That's okay though. Oops. Nonsense is better than no sense. In other words, the radio was working to some degree. That's good. Okay, that's it for today. That's enough for today. We just keep plugging along, doing a few more capacitors, and keeping our eyes peeled, watching for flames and other excitement that might occur with this radio. Thanks a lot for watching, and see you on the next video.